Alright, this video now is going to look at how do we work out the latest finish times for each of the nodes. And it's similar to the way that we worked out the earliest start times, except you're just doing the opposite. With the earliest start times, we worked from left to right. We were adding things together, and when different tasks came into the same node, we always took the higher or the highest number. So with the latest finish times, what we're going to do is we're going to work from right to left. Instead of adding, we are subtracting. And when several tasks go into the same node, we will take the lower or the lowest of the numbers. Let me demonstrate how this will work. Now, by convention, the latest finish time on the end node will be the same as its earliest start time. That's just to say that the latest we could possibly finish the last task without holding up the whole project is the same time as the whole project takes. So I'll just write in the same one here, 23 on the top, 23 on the bottom. I then subtract through each one. 23 minus 1 is 22. 22 minus 10 is 12. 12 minus 5 is 7. 7 minus 3 is 4. 4 minus, I'll take this root through here first. So 4 minus 1 is 3, and 4 minus 4 is 0. So I'll sort of leave those to the bottom, because as we've got multiple tasks going into this first node, I'm not sure which one's going to be the lowest one yet. So working back through this, along this arm, 22 minus 1 is 21. 21 minus 10 is 11. And 11 minus 2 is going to be 9. But I'm not going to put that in there yet because I don't yet know which is the lowest number. And then finally along this, 22 minus 1 is 21. So because I've got multiple tasks going into this original node, I know that I want to take the lowest of these numbers. It's not 21, it's not 9, it's not 3, it will be 0, and so I can put in 0 there. And in fact, it's always going to be, if you've done it correctly, it will always be 0, 0 on that starting node where your earliest start time was 0. So the other thing that I'm going to include in this video is to say, what is the critical path? The critical path are those activities that you cannot afford to delay at all without delaying the entire project. So basically what we're looking for is we're looking for activities which, if you delayed them, you'd get longer than 23 minutes. And the way that you work this out is you just say, well, which are the most important activities? Well, if I work out the pasta bit, so boil the water, cook the pasta, drain the pasta, 12 plus 1 will be 13. Well, actually, after 13 minutes, well, actually, I got some time there. I've got some spare time, so that's okay. Let's see. Certainly, it's not going to be on this one here because it only takes 1 minute to grate the cheese. But nothing depends on grating the cheese. It just has to be ready by the end. So the critical path is actually that sort of longest path in between, which says, okay, between C and B, it's actually chopping the veggies takes longer, so I'll show the critical path by putting a little hash mark in there. It'll then be this line through here. So the critical path will sort of go C, G, H, and I, because we can only finish task I, we can only start it after 12 minutes, and it'll take us 10 minutes to do. So by the time that we get to here to node 7, we don't really have any slack on this path here, and therefore J, because it's the last task, will also be on the critical path. So if you wanted to say the critical path of this, you can say critical path is equal to C, G, H, I, and J, because if you mess up or if you delay any of those activities, then you're going to you're going to take a bit longer with the meal. And so that's why it's useful for business, because a business can draw out the diagram and say which are the most important activities to do.